Okay, so earlier today, we were talking a little bit about HTTP and HTTPS and web protocols in general. So now we're going to go over exactly what that is and what it means for web development as a field. So HTTP stands for Hypertext Transfer Protocol. So the protocol was originally described in 1991, and the origins of hypertext date back to as early as 1930. And hypertext is essentially the precursor to HTML. And so the protocol, HTTP, was originally designed as a protocol for transmitting this hypertext. And that's the origin of what would eventually become the internet as we know it. Today, HTML has grown to support much more than just linking from one page to another. It was the concept of linked pages that created the early web. HTTP has also found new use cases. While transferring HTML is a common one, HTTP can transfer any type of document or file. So when you stream something from Netflix, that's being transferred by HTTP, even though it's not HTML. So HTML isn't even the most common type of document transmitted over HTTP. You get images, CSS and JavaScript, API responses. That's all far more common as a whole than just loading web pages. So an HTTP protocol, it describes a conversation between two parties, the client and the server. The client sends the HTTP request, and the server sends the HTTP response. So both these requests and responses are plain text. You can read them by a human, and each has a very simple structure. So before we get into that, just kind of going, this is how the internet works. If I type in codeplatoon.org into my browser, which is the client, makes a request of the server which hosts codeplatoon.org. That server gets the response and returns all of the documents we need to load this page, including the HTML documents, the CSS, the JavaScript, all of the images. Every single one of those get returned to me as part of this HTTP conversation. And that's the way the internet works. So the actual request and response, we're going to go over what those actually look like. So on the left, we have a request that says get to /bio.html, HTTP 1.1, post example.com, user agent Google Chrome 52.34. And on the response, we've got 200 OK, HTTP 1.1, content length 424, date sat 31 December 2016, content type is text/HTML. And then we've got some HTML right here, HTML head, Superman biography, etc. And we're going to go, kind of take these apart bit by bit. But before we do that, does anyone have any questions about what I've mentioned so far about HTTP being a conversation between clients and servers? Okay, let's break down an HTTP request then. So first is the first line. We have, this is called the request line. It's made up of three parts. The method, which is called get, the URI, which is the /bio.html, and the protocol version, which in this case is HTTP 1.1. So HTTP verbs are essentially say what type of request you're doing, and different request types have different effects. There are a lot of those. Here are the four most common. So GET requests are whenever you want to retrieve a resource. So typically, whenever you visit a web page, you're making a GET request because you want to get that information from wherever you're looking. A POST request is when you send a resource. So whenever you make a post on social media of your choice, whenever you edit Wikipedia, whenever you create a new article on Wikipedia, anything like that, you're making a POST request. A put request is when you're updating an existing resource. So whenever you want to edit something that already exists, you're making a put request because you are essentially getting, accessing an existing line in a database and updating it somehow. And then a delete request specifically deletes something. And we're going to, over the course of the next week or so and the rest of the program, you're going to be making all 4 of these types of requests. So you are going to get into see more detail on how they work. The second part is the URI, which stands for Uniform Resource Identifier. And URI looks a lot like URL, which I'm sure is an acronym you're all familiar with, right? So the URI is specifically the last part. So we have a last part of the thing. So if I go to Code Platoon and click on Intro to Coding here, my URI is this extension at the end, Intro to Coding. So in that case, they have bio.html is the URI. The host name combined with that is the URN. So example.com/bio.html. And when you add the protocol at the beginning, the http:// that turns a URN into a URL. So often when you type things into your browser, you're actually typing in a URN, not a URL. And the browser kind of auto-completes by adding your request type at the beginning. So that's the first part of the request line. What questions do you have about the request line before we talk about the next part? Okay, so after the request line, there's always a space, and then you have headers. And the headers are where you put additional information about the request, like the host you're going to, example.com, and the user agent, meaning who's making the request, which is typically your browser, Google Chrome 52.34. There can be other information including content type. So what type of content? This is a post request. So it's making a post request to a search to example.com/search. And the content type is application/x www form encoded. And then an optional thing you can include is the body, meaning that's actual data that you're including with your request. In this case, we have a query looking for new Jordans that are red from example.com/search. So when you type something into Amazon, go to amazon.com. And I type in new red Jordans. New red Jordans gets sent in as a header, as a body. But it can also be sent in as query params. So you may see up here, it actually says it's the URL that we went to was s_k equals new plus red plus Jordans and ref equals nbsbn nos. So these are called query params. So it's essentially taking that body info that we saw on the last slide and putting it as part of the URI. So query params are always separated from the rest of the URI with a question mark, and individual query params are separated by the ampersand. So they can be combined with request bodies as well.
And I think GET requests, you can only extract data from the URI or the URL, right? I think so.
I feel like you can add a body to a GET request, but it's very uncommon. So typically you will use query params instead. But I may be wrong about that. I feel like I saw that once somewhere, but I may be misremembering as well. So other types of request headers you may find. So the most common one is host example.com. So that would tell the web server which domain the client is requesting content from. So often a single web server will serve content from multiple domains. They're sometimes called virtual hosts. The server uses this uses this header to determine which content to serve. You can have an accept language thing, which just says, I want it in English or Spanish or what have you. The user agent, again, is saying what type of client sent the request. And accept is saying what type of response we're expecting back. So either like text HTML or plain text or an image or JSON or something like that.
Sorry, I just checked. The data and GET requests are sent in the URL, whereas POST requests, it's sent in the body.
Right, thank you. Yeah, so you can have a request body with a GET request, as it turns out. Thank you. All right, any questions about HTTP requests? Okay, let's talk about responses. So responses are divided into a status line, headers, then a blank line, and then an optional body. Just like a request is, with a few differences. So the first part is the status code, the reason phrase, and the HTTP version. So status codes you've all seen in the web before. They tell the client the result of the request. So 200 means everything is working the way it should. A 302 is a redirect. An error 400 is a bad request. Error 401 means you're unauthorized, you can't see it. 404 means you're looking for something that can't be found. And an error 500 means there's an internal server error. So there are actually dozens, if not hundreds, of status codes. Typically, if it starts with a 2, it means it's a success. If it starts with a 3, it means you've been redirected somehow. If it starts with a 4, it means there was a problem with your request in some way. And if there's a 5, it probably means that there was a problem on the server side instead. So for example, if you look for something and get an error 404, it means you were making requests to something that doesn't exist. Or a 401 would say you're making a request to something that you aren't allowed to see for whatever reason. There's actually a cute, fun thing I just want to show you while I got you here. I believe it's cats as status codes. http.cat. So there's things like a 200 is okay. 404 not found. So it's just a fun way to learn some things about HTTP status codes. Even though it doesn't actually tell you anything particular, we can see something like, 503 service unavailable. It's got a cat in it. So the response headers, so they serve a similar purpose as the request headers. They give us additional context that the client uses to interpret the response. So things like what type of content it is, so what format is the response body in, how long it is, which means how many bytes long the response body is. This is things that like set cookie, so this is where cookies come from. And the date of when the response was actually set, including with time. So HTTP conversations, they're not quite as simple as you send one request, you get one response. Whenever you visit a page, there are dozens or hundreds of HTTP conversations taking place in rapid succession. So when you load the home page with the HTML, that's one request and one response. When you get the CSS, that's another request and response. The JavaScript is an additional request to response. And then every image on the page is an additional request and response per image. So you may have noticed that if you're visiting a particularly slow website, it's always the images that load last, and they always load one at a time. That's because there's a delay between each image making a request for each image and getting the response back. And that's just for one single page. So any questions about the request response cycle? Okay. So I mentioned earlier that HTTP is stateless, and this is an important thing. So essentially, whenever you have a request response cycle, that conversation, it shares no state with any previous conversation. So it begins with a brand new connection from the client to the server. It's like they're meeting for the very first time. Even requests that you make just moments before, they don't change anything on the current request. And so often the information is stored on the server side. So they clear all the state variables with each request. That means all state when processing a request comes from the request itself. So they don't typically store anything. And that's why we use something like cookies. So HTTP cookies retain state like who is logged in or what was their last search across multiple requests. And it might sound like a violation of what HTTP being stateless, but even with cookies, the protocol itself remains stateless. Cookies are implemented in a different way. So the server sets cookies by sending them to the client as part of the response. The client stores the cookies. The server doesn't store any itself. So any cookies for the current domain are sent to the server as part of the request. So it's like if you had a friend who had just couldn't remember anything. So every time you visit, you give them like a note card that has your last conversation on it. And every time you see them, you bring them a new note card, but they're the ones that hold on to the note cards and read it so that they remember what the last thing you talked about was.
Like 50 First Dates with Adam Sandler.
Yeah, kind of like 50 First Dates starring Adam Sandler. So in summary, it's a proven protocol. It's extensible and has found uses far beyond what was imagined in 1991. It's relatively simple, it's human readable, and it's easy to parse using code. So HTTP first changed the world by connecting users and servers to form the web, but today it's the foundation of so much more, and you'll soon realize that HTTP is everywhere. So
You're going to be doing this. Oh, sorry.
Go ahead, Tom.
I was going to say, yeah, you're going to be doing HTTP in one of your challenges today, tomorrow, and Friday.
Yep.
So this information is very relevant to the challenge.
Yeah, you're going to be making your own HTTP server as one of today's challenges, and that's going to continue for the next several days. What questions do you have about HTTP before we take a short break? Okay. So